This is ANGSUMAN Khan from Electronics and Communication Engineering Department, UEM Jaipur. Today my topic of discussion is signals and systems. This topic or this subject is very important for undergraduate students basically, and in this subject or in this topic mainly I shall focus on properties of signals, properties of systems and principles of systems, as well as interplay between signal and system and their applications. Okay. Before entering this topic, first I have to know or we have to know that what is a signal. A signal, it is a physical quantity which carries some information and it varies with time or space or both. Okay. Got it? So, a signal is a physical quantity which carries some information and varies with time or space or both. Not only that, it is a single valued function. We can express as function, we can express this signal as a function, and it is a single valued function of one or more independent variables. It may be a single valued function of one variable, it may be a single valued function of more variables. Got it? So, now we have to know few fundamental classifications of signals. Okay. First one is that single channel signal and multi channel signal. Single channel signal means single source signal, like the mono sound of audio speaker. Okay. So, this is single channel signal or single source signal, and there may be multiple channel or multi channel signals, multiple sources are there, like the electrocardiograph curve, ECG. Okay. So, these type of signals they are either they will be single channel or multi channel. Next one is that one dimensional and multi dimensional signal. In case of one dimensional, we generally express one dimensional signal as xt. Okay. So, t is the independent variable and this signal depend on t. Okay. This signal depend on t, where t is the independent variable. So, this is one dimensional signal, one independent variable t is there and signal is dependent on one variable, but there may be multiple dimensional signal. Okay. Any if we may consider any spatial coordinates x, y, z. Okay. Signal may depend on more than one dimension. Okay. Multiple dimension. Let p x, y. So, this signal depends on x and y. These x and y they are independent variables, but the signal depends on this x and y. They are independent, x and y they are independent variable, and p dependent on this x and y. So, this is another type, one dimensional and multi dimensional signals. And next one is very important, analog signal or continuous time signal, discrete time signal and digital signal. So, first of all, what is analog signal or what is continuous time signal? Continuous time signal is that signal which is continuous in time as well as continuous in amplitude. Got it? Any real time, any real life signals, those signals are analog signals or continuous time signals. So, continuous time signals they are continuous in amplitude as well as continuous in time. Now, next one is what is discrete time signal. If continuous time signal is passing through a sampler, then it will produce a discrete time signal. So, discrete time signal is the sampled version of analog signal or continuous time signal. Got it? And discrete time signal it is continuous in amplitude, but discrete in time. Do not forget, discrete time signal is continuous in amplitude, but discrete in time. In general we represents this discrete time signal as xn, but in case of the previous one, that is analog signal or continuous time signal, the representation is xt, where t is the independent variable, here it is n. Okay. each instant will be represented by this n. Okay. So, xt is the continuous time signal, is the representation of continuous time signal or analog signal, xn is the representation of discrete time signal. And the next one is very important, what is digital signal? Digital signal is the quantized and coded version of discrete time signal, and this digital signal, it is discrete in time as well as discrete in amplitude. Got it? So, digital signal is the quantized and coded version. Okay. So, after sampling this signal, this discrete time signal, now it is passing through a quantizer. Okay. So, after quantizer and coding, it will produce one digital signal. So, again I am repeating, analog signal or continuous time signal, it is continuous in time as well as continuous in amplitude, and representation is xt. Discrete time signal, it is continuous in amplitude as well, but discrete in time, representation is xn in general, and digital signal, it is discrete in amplitude as well as discrete in time. Got it? Okay. So, now I have to focus, or we have to know few basic fundamental continuous time signals. Okay. I will discuss about discrete time signal later, but first I will focus on continuous time signal. So, first of all, impulse signal. What is impulse signal? You know, impulse signal, it is represented as del t. Okay. This is the representation of impulse signal. Now, del t is equal to infinite if t is equal to 0, okay, is equal to del t is equal to 0 if t not equal to 0. This is the functional representation of impulse signal. Not only that, you have to mention when you are defining this impulse signal, you have to mention that the area under the curve is equal to a. A is any, it is the area, a is any positive constant. So, minus infinite to infinite del t dt, this is equal to a. Okay. So, the actual definition of impulse signal is that del t is equal to infinite for t is equal to 0 and del t is equal to 0 for t not equal to 0, and you should mention that area under the curve is equal to a, and the waveform by which you can represent this impulse signal is this. So, this is time axis, this is the amplitude axis, and this is delta, and it at t is equal to 0, when t is equal to 0, it is infinite, goes towards infinite. Now, thing is that what is unit impulse signal? Unit impulse signal is, the definition is same, but the area under the curve is equal to 1, okay, and the representation is obviously same. Okay. So, again I am repeating this, what is unit impulse signal, that is del t. If del t is one unit impulse signal, then del t is equal to infinite for t is equal to 0, and del t is equal to 0 for t not equal to 0, and the area under the curve is equal to unity.